And we're back. You probably noticed I didn't do number 14. Most people got it correct about what's any number divided by itself is 1. So I skipped over 14. 15 through 18 are just kind of definitions and terms. So these are things that like I refer to a lot when I'm explaining different problems. So these are really good words to know. So a constant term, well, let me go back to this actually. Most people I would say got 16 and 18 correct, got variable and exponent correct. So variable you're used to is the letter, was x, and then exponent is the little top number, the superscript, so exponent is 3. So most people got those correct. What they mixed up a lot were the constant term and the coefficient term, which I can see happening because they both start with C's. But if we think about what the word variable means changes. So because it's a letter, we know that we can have different values for a variable, so that can change. So then if you think about constant term, what constant term means, constant means it doesn't change. So that means there's no variable. So the constant term here is actually 5. The constant term is a term without the variable because that number is not going to change because it has no variable with it. So you'll see also down here, a constant is a number, decimal, or fraction on its own without any letters. Okay, so in this one, this is kind of similar to the one that we had here. 7 was the constant. And the expression on the, oh, whoops, that's ugly. And the expression on the basic skills test, 5 was the constant. And then coefficient. So we think about what the prefix co means. It means like shared. So, or with something. Like co-educational means, boys and girls going to school together. Cooperative means working together, so together or shared, something like that. So your coefficient is the number in front of your variable. So your coefficient is 18. So it's the one that's with, co meaning with or shared with your variable. So you'll see here 6 is the coefficient in this first box. 4 is the coefficient in this one. And you can have more than one coefficient in an expression or an equation. It just depends on how many variable terms that you have. So those are just the terms, but those are really important things to know. So if I say, you add the coefficients, will you add the numbers in front or something to that effect? All right, next, reciprocal. This one did not go so well. So reciprocal. Reciprocal meaning, like if you think about like reciprocate, that means you do something for somebody and they do something for you. So you it means like back and forth. Like if I, give you an A, you're going to reciprocate and give me $100, right? So reciprocate is kind of like two ways. It's kind of going back and forth. So reciprocal is when you swap the numerator and the denominator. By the way, I will not give you an A for $100. Many people have already offered, and I will not take you up on it. Sorry. So anyway, swap the numerator and the denominator. So here it tells you 9 over 7 is the reciprocal of 7 over 9. So that's all you do is you flip it over. So the reciprocal of 3 over 5, flip it over, is 5 over 3. Okay, so that's all that one is. So sometimes we need to use the reciprocal when like we multiply fractions or something like that. Or I take it back. When we divide fractions, sorry. We divide fractions, divide fractions, we multiply by the reciprocal. Or when we solve equations, we may have to multiply by the reciprocal. And actually, before I forget, so reciprocal, actually, this goes back to the inverse property. So when you multiply a number by its reciprocal, like we did 2 times 1 over 2, if you multiply a number by its reciprocal, this is the inverse property, because multiplying a number by its reciprocal is 1. Okay, opposite. So what opposite means? Opposite numbers are the same distance from 0. The opposite of -2 is +2. I know some of you in your classes right now, depending on what course you're in, you're talking about absolute value right now. And we've talked about how two numbers have the absolute value, the positive and the negative. So that's kind of what an opposite means. So it's the same distance on the number line. So opposite just means change the sign. So the opposite of 3 over 5 is just going to be negative 3 over 5. So opposite is just referring to the sign. And if you look down here, it gives you some examples. So you have a real number, you insert the minus sign, and you get the opposite. So the opposite of a negative is actually a positive. So it just means change the sign. So two negatives make a positive, so the opposite of a negative, again, is a positive here. That's all you do, literally, is you change the sign for opposite. Let's see what the next page is. I might stop here. Okay, we'll do this one. All right, so select all of the numbers below that are perfect squares. So perfect squares are numbers that have a square root. So means that a number times itself, a certain number times itself equals that number. So like here are some examples of square roots. Sometimes you'll see it defined as a number how do I want to word this? Look at these diagrams. A number whose square root is the side length of a square, or a number who is equal to the area of a square, something like that. Because these square numbers means like we have these squares, that's 2 by 2. So 2 times 2 is 4. We have a square that's 3 by 3. 3 is a side length for both. So that's 3 squared, 4 squared. So all of these numbers you can make squares out of because the side lengths are going to be the same. So if we think about this, it's just if you were to take the square root of a number, it would be a whole number. Or if you squared a certain number, it would equal this number. So there's really nothing that can square to equal 11 because 11 is actually prime. So the only factors of 11 are 11 and 1. So that's not going to work. Then when we think about 9, we have 1 and 9, but then we also have 3 times 3. So the square root of 9 is 3. So 3 squared equals 9. So 9 is a perfect square. 2, again, is prime. So 2 times 1 are the only factors. So 2 cannot be a perfect square. 8, it has a lot of people answered 8, and I kind of purposely threw that on there to trick you. But 8 is actually 2 to the third power, not 2 to the second power. So 2 times 2 times 2 is 8, so it's 2 to the third power, but not 2 to the second power. There's no number times itself that's going to equal 8. And then if we think about 100, 10 times itself, 10 squared is 100. So 100 is also perfect square. So for this one, the answers were B and E for perfect squares.